So let's show how to construct a middle Riemann sum. And to do this, we're going to use the same function and interval that we used in the previous video. So we want to consider f of x equals x squared on the interval -2 to 3. In the process of constructing a middle Riemann sum, we'll also have to specify the number of subintervals. So in this case, we'll go ahead and assume that the number of subintervals is equal to 5. So before we can provide the expression for the middle Riemann sum, we need to set up some geometry. So we're going to go ahead and we're going to graph f of x equals x squared on the interval -2 to 3 one more time. So now what we do is we think about what it means to have 5 subintervals. So if you look at this, you'll notice that the interval goes from here to there, okay? The distance between -2 and 3 is 5. If we take a length of 5 and divide by 5, that gives us 1. So what that tells us is that each subinterval has a width of 1. So the first subinterval is going to be from -2 to -1. So this will define, if you like, the first subinterval. From -1 to 0 will define the second subinterval. The subinterval from 0 to 1 will define the third. The fourth is from 1 to 2. And the fifth is from 2 to 3. So these 5 subintervals are going to define what we call as the partition. So the partition here is composed of these 5 subintervals. Right? Now let's introduce the notation x sub I. So x sub I is going to denote the end points of the subintervals. And we start listing these with a value of I of 1. So x sub 1 is going to be equal to 2. X sub 2 is going to be equal to -1. X sub 3 will be equal to 0. X sub 4 will be equal to 1. X sub 5 will be equal to 2. And x sub 6 will be equal to 3. So x sub 1 through x sub 6 define the points on the interval -2 to 3, which define the partition of this particular interval into these subintervals. All right. After we define the x sub i's, we want to define the x sub I stars. Okay. So the x sub I stars are going to denote the center of the intervals. So what we do is we start with the first subinterval, which is right here, and x sub 1 star is going to denote the center of this subinterval. The reason that we're interested in the reason that we're interested in the middle of the subinterval is because we are interested in the middle Riemann sum. If we had been interested in the left or right Riemann sum, then we would pick an x sub I star at a different location. So the x sub 1 is simply going to be there. So that's going to be x sub 1 star. Then this is x sub 2 star, x sub 3 star, x sub 4 star, and x sub 5 star. So x sub 1 star you can calculate as simply -1.5. So x sub 1 star is the center of that interval, which you can calculate by simply averaging -2 and -1. X sub 2 star is going to be at -0.5. X sub 3 star is going to be at 0.5. Okay, x sub 4 star is going to be at 1.5. And then x sub 5 star is going to be at 2.5. And again, the reason that the x sub I star is at the center of these subintervals is because we're interested in calculating the middle Riemann sum as opposed to the left Riemann sum or the right Riemann sum. Now, once we've constructed these x sub i's and x sub I stars, then we can create our rectangles. So since we have 5 subintervals, we're going to have 5 rectangles. So the way that I construct the rectangle is I go to the center of my subinterval, and that's going to give me the height of a rectangle. And then the width is simply the width of that subinterval. So this distance right here is f sub x1 star. Okay, this distance right here is x2 minus x1, which in this case is simply 1. That's the width of that interval. So the area of this rectangle right here is simply the product of this and this. We'll also refer to this as delta x1, which is in this case simply 1. So again, the area of this rectangle right here is going to be f sub x1 star times delta sub x1. In this case, that would be f of minus 1.5 times 1. Okay? And since f is x squared, that's going to be minus 1.5 squared. Okay? So again, what we can do is we can create the remaining rectangles like this. Running out of room, sorry. It's right there. Okay. So again, we construct the area. We can construct these little rectangles for each of these subintervals. Now, if we take all of these rectangles, or the area in all these rectangles, and add them together, we get what is called the middle Riemann sum. So the middle Riemann sum is the area of all the rectangles which we can write as the sum I equals 1 to 5. And again, 5 because there's 5 rectangles, which is the same as 5 subintervals. Okay. Sum of f sub x sub I star times delta sub xi, which for us is simply summation I equals 1 to 5 f of x sub I star, since delta sub x sub I is equal to 1.